Math 3 Lesson Summary Video. Sining and cosining. This is a solidify understanding task, which takes concepts developed previously and helps you formalize those ideas. The purpose of this lesson is to find the relationship between sine and cosine of an angle and its point of intersection on the unit circle. In the previous tasks of this module, you have used the similarity of circles, the symmetry of circles, right triangle trigonometry, and proportional reasoning to locate stakes on concentric circles. In this task, we consider points on the simplest circle of all, the circle with a radius of 1, which is often referred to as the unit circle. Here is a portion of the unit circle, the portion lying in the first quadrant of a coordinate grid. As in the previous task, staking it, this portion of the unit circle has been divided into intervals measuring pi/8 radians. As in the previous task, find the coordinates of each of the indicated points in the diagram. Also, find the arc length S from the point 1, 0 to each of the indicated points. So if you recall in our last task, we already figured out what these points would be at pi/8, pi/4, 3 pi/8, and pi/2 radians for a 10-foot circle. It had a radius of 10 feet. And if you go back and look at what those points were, we had 9.24, 3.82, we had 7.07 and 7.07. We had 3.82 and 9.24 and then 0.10. So these were the points for that 10-foot radius circle. We also talked about last lesson that if we wanted to find those points for any radius circle, that they were all going to be proportional to that. And since this one had a radius of 10 and the one we're looking for now has a radius of 1, that gives us a scale factor of 1/10. We want all of these points and all of these measurements to be 1/10 of what they were on the 10-foot radius circle. So if we just take all of these points and we divide them by 10 using that proportionality concept, we're going to get that this point is 0.924, 0.382, this one is 0.707, 0.707. This one is 0.382, 0.924, and 0.1. So we're still using that same proportionality concept that we had yesterday. Yesterday we were finding 20 foot, so we multiplied everything by 2. When we found 40 foot, we multiplied everything by 4. Now we're going smaller, but it is still proportional. So we can figure out what those points are, still using that same proportionality concept. If we wanted to find that arc length, we also said yesterday that that arc length had to be proportional. If you recall yesterday, the arc length for the first one was 3.93, which would, if we use that same proportionality concept and divide it by 10, would make this arc length S would equal 0.393. And if we use the same proportionality concept as yesterday, we said all of these little arc lengths are 0.393. So if we have 2 of them, we just need to multiply by 2, which is going to give us 0.785. And if we have 3 of them, we're just going to multiply by 3 and get 1.178. And if we have 4 of them, when we multiply by 4, we get 1.571. So we can find all of those arc lengths and all of those points using that same proportionality concept that we talked about yesterday. With your calculator set in radian mode, find each of the following values. Record your answer as decimal approximations to the nearest thousand. So on your calculator, if you have never actually set your calculator to radian mode, if you go to the mode button, you'll notice that the third row, radian and degree, are both options. Up to this point in your career in math, you've used mostly degree, and your teacher probably made a very big deal about making sure that your calculator was set in degree mode and not radian mode. But now we're actually going to get to use radian mode. So we want to make sure that our calculator is on radian mode, and we want to find what are some of these calculations. What is the sine of pi over 8? What is the cosine of pi over 8? What does pi over 8 itself equal? And we want to look for some patterns that go along with our picture on the page before. So if we actually find all of these calculations, the sine of pi over 8, we get that it is 0.383. And if we find a few more, cosine ends up being 0.924. Pi divided by 8 is just equal to 0.393. Sine of pi over 4 is 0.707. Cosine of pi over 4 is 0.707. And pi over 4 itself is equal to 0.785. And what we want to see is, do we notice any patterns in that? Does that match anything from our picture? Does anything look like it goes with it? One of the things that I notice is that for pi over 8, cosine was the same as the x value of the coordinate point. Sine was the exact same value as the y coordinate of the coordinate point. And pi over 8, its decimal, was actually equal to the arc length for that point. And when I match that up against pi over 4, this was also the x value, this was also the y value, and this was also the arc length. In fact, for all 4 of these points, the sine ended up being the y value, the cosine ended up being the x value, and the radian measure actually ended up being the arc length. The coordinates and arc lengths you found for points on the unit circle seem to be showing up in Javier's computations. Why is that so? Explain why the radian measure of an angle on the unit circle is the same as the arc length. If we think back to the definition of a radian, back in the circle unit, we said that a radian measure is the ratio between the arc length and the radius. It's just a proportion. It is a ratio of the arc length divided by the radius. In this situation, in the unit circle, it just so happens that the radius is equal to 1. So when the radius is equal to 1, we're taking the arc length and we're dividing it by 1. And so that's why in the unit circle, the radian is the arc length. Explain why the sine of an angle measured in radians is the same as the y-coordinate of a point on a circle. Thinking back to lessons 1 through 5, we worked with that Ferris wheel and we very quickly figured out that the y-coordinate, that height that it was above that midline, was equal to the radius times the sine of the angle. That was the whole building block that we built the sine function on. And again, if our radius is going to be equal to 1 times the sine of theta is just the sine of theta. And so for the unit circle, because its radius is equal to 1, the y value is the sine of theta. Very similarly, we figured out that the x-coordinate was equal to the radius times the cosine of theta. And if the radius is equal to 1, then x is equal to the cosine of theta. So based on all of this work, find the following without using our calculator. So here we have the whole unit circle. we figured out that this point was 0.924.382. And we figured out that this point was 0.707.707. And we figured out that this point was 0.382.924. And we knew this point was 0, 1, and this point is 1, 0. So now we want to try and use that information. We don't have a calculator. We're not going to use a calculator, but we want to use this information to help us find these values. So the sine of 5 pi over 8. Well, where is 5 pi over 8? If you remember, we were counting by eighths. So this was 1/8. This was 2/8, which is 1/4. This was 3/8. This was 4/8, which is 1/2. 1/2. 5/8. So here's 5/8. So 5 pi over 8 is this angle right here. Think about all the symmetry that we've been using for the circle. We knew in the Ferris wheels that these two were the same height above, and so they're symmetrical across this horizontal line, the y-axis. So if this one's point was positive 0.382, positive 0.924, this one is going to have a point of negative 0.382, positive 0.924. And what we just conjectured on the previous page is that for the unit circle, which this is the unit circle, it has a radius of 1. For the unit circle, the x-coordinate is always equal to the cosine of that angle, and the y-coordinate is always equal to the sine of that angle. So for 5 pi over 8, the sine of 5 pi over 8 must be 0.924. And I didn't have to use my calculator. The cosine of 7 pi over 8. So this was 5 pi over 8. This would be 6 pi over 8. And this would be 7 pi over 8. So this angle right here is going to have symmetry with this angle over here. So its coordinate is going to have to be negative 0.924, positive 0.382. And again, we know that our cosine would have to be the x value and our sine would have to be the y value. So it asked for the cosine of 7 pi over 8. So that's going to be negative 0.924. And if we want the cosine of pi, let's see, where would pi be? Pi is all the way across the circle, halfway. So this is where we get pi. And when we have pi, it lines up with the point 1, 0. But it's going to be symmetrical on the other side, so it must be the point negative 1, 0. And if cosine is the x value and sine is the y value, then the cosine of pi must be negative 1. This is the power of the unit circle. In the unit circle, by knowing the points on the circle, when we know the points on the circle, we know the sine and the cosine. If we want to find the arc length on the unit circle, then all we have to do is actually find the radian measure. This arc length will be pi over 8 because its radian measure is pi over 8. And there's a lot of use to having that. We use decimals on this unit circle. But as we move forward, we are going to talk about what are these exact points, and then how we can use that to help us find exact sines and cosines, which will get much more useful the higher up in math that you progress.